This is the video for Unit 8, Lesson 5, Applications of Linear Systems. So our goal is going to be using properties that we've learned with elimination and substitution to solve word problems. This is similar to some of the topics you saw back in Math 1, and again, we're just kind of revisiting them so that we're good and fresh with them for the SAT. So the first question we have here, and again, this is our just writing systems and solving, says that Home Depot charges a flat fee of $25 plus $4 per day to rent a snowblower. Menards charges a fee of $27 plus a fee of $2.50 per day to rent the same snowblower. And the directions just simply say write a system to represent the cost C of renting a car or agency for D days. So this is an example of one where you're looking for keywords and values in here. So we see we have a flat fee of $25. Anytime you see the word like a flat fee, that's usually meaning you're paying at one time. And then when it says a rate up per day, that's usually going to act like almost like a rate or a slope, right? So we're used to using X's and Y's, but now they're going to have us use C's and D's. So C is the cost in relation to D days, like how much are you paying after so many days? This one is actually, we're going to write it almost in slope-intercept form. So C for cost, it's $4 for every day plus that flat fee of $25. And this would be what we had for Home Depot. The second equation, because it's a system, so we need more than one equation, is talking about Menards. So Menards gives you the cost is different. It has a flat fee of $27.50 and $2.50 per day, so $2.50D plus $27.50. The flat fee for a lot of times is going to act like your y-intercept when you're writing. These problems usually are going to be in slope-intercept form. And this would be my system. It's not asking me to solve it, so that would be my final answer. For example 2, this one, we're going to solve it out, but again, the solving is not new. It's more the writing. So how do we pick out what we need to do? So this one, I like to call like a combination problem. We have two items that we're buying in different combinations, and we're getting different totals. So it says Mary and Asanji are selling cheesecakes for a fundraiser. The customers can buy French silk cheesecakes and chocolate marble cheesecakes. And they give you different combinations. So Mary sold 4 cheesecakes and 14 chocolate cheesecakes and got $302. And then it says Ajani sold 12 French silk cheesecakes and 7 chocolate marble cheesecakes for $241. And they want to know the cost for each. So let's say, for example, I'm going to let them be X and Y. Let's say X is going to be the French silk. Y is going to be the cheesecake. Or no, they're both cheesecake. The chocolate. And so now we can write our combinations here. So 4 French silk plus 14 marble. So don't forget I called it Y, is equal to 302. So that's one problem equation. And then the second equation would be 12 French silk plus 7 marble is 241. So if the question just simply asked you to write a system, you can do just that. You would be done. This one actually wants you to solve it out, though. So you can do any type of elimination you like. You can eliminate the X, you can eliminate the Y. I'm going to eliminate the Y just because usually we've been doing the X or the first term. So if I multiply by -2, I can get an opposite for that 14y. So I'm going to rewrite it. So 4x plus 14y is 302. Negative 24x minus 14y is negative 482. And then we're going to go ahead and add them up. So negative 20x equals negative 180. And then if we divide, we're going to get that to be 9. If we want to solve out for y, we can pick any equation we like. We could do the new one, we could do the old one. It doesn't matter. I'm going to maybe use this top one here and just substitute that 9 in and solve it out. So if we go ahead and solve this out, nothing too different than what we would normally do. And then we would actually get our answer when we solve this out to be 19. So we have 919. But for a word problem, this actually has meaning, right? So basically, this is the price per cheesecake. So that means French silk is $9. And then the marble cheesecake is $19, right? So it actually has meaning. It told us the value for each of those. The you try, we're going to have you try out. And then example 3 is talking about money and number of coins. So these are common problems to see. So the idea is if you have 5 coins, that doesn't mean you have $5, right? The coins have different value. So however much money that is not the same as the quantity of coins you have, right? The value of the coin and the quantity come into play. So this one says Cynthia has 3 10 in nickels and quarters. We're using here, we're comparing nickels and quarters. The number of quarters is 2 less than a third of the nickels. And they give you what the variables represent in this problem, right? So they're telling you that X is the number of nickels and Y is the number of quarters. Okay, so when we go ahead and write this out, we have 2 different equations. So we have how much the values, right? So a nickel is 5 cents. So if I write that as a decimal, that's 0.05, not 0.5. That's the value for each nickel. And the value for each quarter is 0.25 Y. And that's going to add up to $3.10. For the number of coins, they give us a different relationship. So and this kind of goes back to a math 1 skill. The number of quarters, I could actually translate the sentence. That's going to be Y. It is the same as equals. And then 2 less than a third the number of nickels. So 2 less than whatever a third is. So it'd be 1/3 X minus 2. That 2 less than means minus 2 at the end. So if I write this out, I have 1/3 X minus 2. And this is my system of equations we're going to solve. So substitution would probably be the easiest here. You can use decimals if you like, but if you don't want to work with decimals, you can actually clear the decimals out. So you kind of have some options here. I've had it where some students don't like this, and they'll multiply the top by 100 because there's 2 decimal places. And so this would then become 5x plus 25y equals 310. And then they're solving something that they're a little more comfortable with. And you could leave it as is and just work with decimals. You will get the same answer. So I'm just going to show that you could clear out the decimals if you want. You don't really have to. It's really more just a preference. And now we're going to go ahead and use substitution. So wherever I see a y, I'm going to put that expression in. I know I did it correctly because I only see y's here. And now we're going to go ahead and distribute 25. I'm going to make that 25 thirds minus 50 equals 310. I can make that 25 thirds into a decimal if I really want to. We could also, if we want to, use our calculator to combine the 5 and the 25 thirds. We have that nice fraction, and that would be 40 thirds. And then add and solve. If I have 40 thirds, it's the same as multiplying by the reciprocal, or I could divide it. So if I multiply by 3/40, Or again, if I divide it and just use a parenthesis, that would give us our answer. So I could do 360 times 3 over 40. And then we would get 27. If I want to finish the problem off, now I need to find my my y value. I could just go back to where I just were at the very beginning and put in 27 times 1/3. And then we would get that to be 7. So my answer would actually be, because again, these had meaning, so 27/7 was the answer. So that means you had, if X was nickels, there was 27 nickels and 7 quarters. And that would be it. For the last example, this one you're just writing a system, so you don't have to do anything extra here with solving. This one says Anna paid $3.70 for 20-cent stamps, 5-cent stamps, and 3-cent stamps. She bought 50 stamps altogether, and then they give you a relationship where the number of 3-cent stamps is 10 more than half the 20-cent stamps, and they give you what everything represents. So they're telling you X equals number of 20-cent stamps. They're telling you Y is the number of 5-cent stamps. And then they introduce a third variable, so Z is the number of 3-cent stamps. So we're going to have some equations here. We have one that represents the value. So 20 cents, again, is 0.20 X. 5 cents is 0.05, not 0.5, Y. And then 3 cents is 0.03, not 0.3. And that's going to give me $3.70. She brought 50 cents altogether. So if I add X and Y and Z, that would give me 50 stamps. So 50 stamps doesn't mean $50. That's the quantity. And then finally, the number of 3-cent stamps we said was Z. So Z is 10 more than, so 10 plus or plus 10, half the number of 20-cent stamps. So half the number of 20-cent stamps, we add 10 more. And this would be our system, and then we would be done. If you have any questions, you can feel free to ask in class, sign up for T-Bolt time, or go to the center.